We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, students. Today we'll discuss graph theory in discrete mathematics. The graph theory you have already studied in data structure subject, but still there are some topics which are different from the data structure that we'll study here. So let us start from some basic definitions. The first definition is graph of the relation. Now, what is the graph of the relation? As we have already studied binary relation in our previous chapter, we all know that what is the binary relation. Now consider any set V. V means you can consider any set like V equals to 1, 2, 3. Now if we'll say that if my V cross V, what is my V cross V? That is the cross product of V and V. So here we can get 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3 and 3, 1, 3, 2, 3, 3. So these are all my cross product for my set 1, 2, 3. Suppose here we have taken this set that 1, 2, 3. Now the definition says that it was shown that such a relation could be represented at least in some cases by a diagram which was called the graph of a relation. Now if we represent this V cross V in terms of diagram, then it will become the graph of the relation. Here V cross V is the relation, and if we are considering this V cross V into the graph, into the diagram, then it will become the graph of the relation. Now we'll first consider several graphs which are represented by means of diagrams. Some of this graph may be considered as graph of certain relation, but there are other which cannot be interpreted in this manner. So consider here, we'll see the following figure that represent some of the graph. Here there are some figures. Here we can take V1 and V2. This figure here, V1 and V2 are some vertices. You can take as vertices here V1 and V2, but they are connected. Here V1 and V2 are not connected. Same here, you can consider here V1 to V2. It is the directed edge from V1 to V2. Now next is 1, 2, 3. There are 3 vertices, and 1 and 2 are connected, but it is directed edge. So 1 and 2 is connected, 2 and 3 is connected, and 1 and 3 is connected. So here are some different types of graph that we'll discuss later. But here first of all, what is graph that we are will see. So notice that in each and every diagram consists of set of points which are shown by dots or circle. Here we are seeing that there are some dots or circle we can consider as the vertices. In each and every graph, the graph can have the vertices or any dots that will represent with vertices. So here that are labeled with V1, V2, or we can consider 1 or 2. You can label the vertices as any of the V1, V2, or you can consider as 1, 2. Also in every diagram, certain pair of such points are connected by lines or arcs. So these vertices or these dots are connected with some arc or with some lines, so it will become the edge. So that is the graph. Now next is the other details such as geometry of arcs, their lengths, the position of the points, etc. are of no importance at present time. So here there are other things that we can consider in graph, that is geometry of arc, that is direction of the graph you can also consider in each and every graph. So there are some other points also. So now we'll see the definition of the graph. So first of all, what is the definition of graph? A graph G equals to V E phi. Now what is V, what is E, and what is phi? G means your graph, V means your vertices, H that we have seen that the arc or the line between two vertices, that is consists of a non-empty set we call the set of nodes or points or vertices of the graph, and E is said to be the edge of the graph. Now what is phi? Phi is a mapping from the set of edges E to a set of ordered or unordered pair of elements of V. Here from the definition we can say that what is phi? Phi is the relation between V and E, that is vertices and edges. Now you can see here that there are set of ordered or unordered pair of elements of V. Now what is ordered pair and what is unordered pair? From the ordered pair and unordered pair we can have two types of graph, that are directed graph and undirected graph. Now what is directed graph? Here we have considered that E equals to Vi and Vj. Here I we can consider as 1, 2, 3 or anything, or J we can also consider 1, 2, 3, 4 anything. So here ordered pair. Now what is ordered pair? In the previous chapters we have already considered what is ordered pair. If I can consider 1, 2, then this is, if I can consider this as ordered pair, then ordered must be follow. So 1, 2 and 2, 1 both are the different things. Now they are not same in ordered pair. Okay. Now if we are considering unordered pair, then 1, 2 and 2, 1 is same in unordered pair. So here from in the graph also we are considering here that if you will see the graph here, then 1, 2 and 2, 1 is not same, because here from 1 and 2 it is the directed edge. See here, from 1 to 2 it is the directed edge, and from 2 to 3 it is also directed edge. So here 1 to 2 and 2, 1, 1, 2 and 2, 1 is not same. Similarly 2, 3 and 3, 2 is also not same. 3, 4 and 4, 3 is also not same, and 1, 4, 4, 1 is also not same. Similarly 1, 3 and 3, 1 is also not same. So here you can see this is called the directed graph, and here this is called the undirected graph, because here there is no direction of any edge. So here you can consider 1, 2 and 2, 1 is same, 2, 3, 3, 2 is same, 3, 4, 4, 3 is same, 4, 1, 1, 4 is same, 1, 3, 3, 1 is same. So here there is a difference between directed and undirected graph. In the next topics we can mostly will consider the example of directed graph. So keep in mind that what is the directed graph, where you will have the ordered pair, where you have to compulsory maintain the order of your pair of the vertices. Now what is next? Next is the definition of directed edge. We have already seen what is the directed edge, so it will be easier for us to understand the definition also. Now what is definition? In a graph, G equals to VE, and edge which is associated with an ordered pair of V cross V. We know that what is V cross V, that is the cross product of vertices which consist all the pairs, all the edges of the vertices, is called the directed edge of G. Now here we can consider that an ordered pair of V cross V. Ordered pair means that is the called directed edge of G. Here we can consider what is the ordered pair, that is 1, 2, 2, 3, 4, 3, 1, 4 and 1, 3. These are the directed edge. While 2, 1 is not directed edge, 3, 2 is not directed edge, 3, 4 is not directed edge, 4, 3 is not directed edge, and 3, 1 is not directed edge. So that is the definition of directed edge. Now what is undirected edge? Undirected edge, an edge which is associated with an unordered pair of nodes is called undirected edge. Obviously if you have undirected pair, unordered pair, then it will have 1, 2 is undirected edge, 2, 3, all the edges here in the graph all are undirected edge. So that is the definition of directed and undirected edge. Now the next definition are directed graph, undirected graph and mixed graph. Now a graph in which every edge is directed is called digraph or directed edge. this digraph is very important concept, because in the further topics we'll consider the digraph only. So a digraph in which every edge, if in your graph every edge is directed, then only it will call as a digraph. Here this is digraph because each and every edge are directed edge. Now what is undirected graph? A graph in which every edge is undirected is called an undirected graph. Here this in figure, this figure is of undirected graph because each and every edges of this graph is undirected edge. And what is next? If some edges are directed and some are undirected in a graph, then the graph is called mixed. Now in your graph, if you have directed edge as well as undirected edge, then that graph is also called mixed graph. Now in the previous digraph, B, E and G are directed graph. Now here we can consider this arrow. Here we will not consider this arrow. So B, E and G are directed edge. Here you can consider this B, that is V1 to V2, it is the direction. Here each and every edge are directed, so we can consider this as digraph. And G is also because from each and every edge there is the direction between each and every edge. यहाँ पे सारे डायग्राम में हमारे पास every edge के लिए direction है, so we can call B, E and G as a directed graph. So now what is next? Next we are seeing here that C and F are undirected and D is mixed. What is C and F? See here, we will not consider this arrow here. So V1 to V2, it is undirected edge. So here C is also undirected graph, and C and F. Here X1, X2 and X3. There are no directed edge here, you can see here. And next is D. D is a mixed graph. Here you can see that from 1 to 2 it is direction, from 2 to 3 it is directed edge, but from 1 to 3 it is undirected edge. So here it considered directed edge as well as undirected edge. So here you can consider that it is mixed graph. So here are some definitions, basic definitions that we have considered, that is directed graph, undirected graph, mixed graph. Now what is the next? Next is we can also consider city map which have one-way street. If you have one-way street, then you can obviously consider it directed graph, and if you have two-way street, then you can consider it as undirected graph, and if it has one-way and two-way both, then you can consider it as mixed graph. Now which is the next definition? The next definition is initiating or originating node, or terminating or ending the node. This is also very simple definition, that is what is initiating or originating node U. Now let us consider VE, that is graph, be a graph, and let X belongs to E be a directed edge associated with the ordered pair of node QV. Consider this, consider here, that is UV are the nodes, UV are the nodes and X is the edge. Now what is next? Then the edge X is said to be initiating or originating node U and terminating or originating ending in the node V. So here X is said to be the originating at U and terminating at V. Here we can consider that